In this video, I'm going to run through an example of how to go from kind of a picture or a situation and create your free body diagram and go all the way through to your net force equation with breaking down angled forces with trig. So the first thing that we always want to do is start with our free body diagram. And for this one, I am going to focus specifically on the cart, and a couple of things that we probably want to say or include will be that we have friction between the cart and the incline, and we are also speeding up going up the incline. So that might affect some of our net force equations and how we draw those. So I'm going to draw our cart or our object as this dot, and I'm going to say that's my cart. And I want to figure out what are all the forces acting on our cart right now. So we always have gravity going straight down towards the earth, so I'm going to write my Fg on the cart by the earth. My normal force, since this is kind of an angled component, is always perpendicular to my surface. So my normal is going to be kind of off at an angle like this. I'm going to say Fn on the cart by the incline or the ramp. And it looks like we also have an applied force kind of pulling us up the incline. So I'm going to say we have an applied force, Fa, on the cart by the person. And since we're given that we have friction, that's also one that we have to put down. So it's going to oppose our motion going parallel to our incline. So I'm going to say Ff on the cart by the incline. So it's kind of hard to see which forces are balanced with each other in this case, just because some things are kind of lopsided. So we need to design a coordinate system that we can define what is directly x and what is directly y. And what I recommend is you always use your surface as your x-axis. So I'm going to kind of mess up my free body diagram. Actually, let me draw a new one over here just so we can see the components a little better. So we've got gravity, applied, friction, and normal. Then Fa, Ff, and Fg. Okay. So I'm going to define my coordinate system as this is going to be my horizontal. I'm going to say this is positive and this is negative. It's kind of my x-axis. And I'm going to say that this is my y-axis. So I'm going to say y, and up is positive, down is negative. Okay. So as I look at all of these forces, I want to identify what is completely x and y, and if there's any angle force we need to break down. So it looks like Fa is right in that horizontal, so I'm going to try to kind of overlay it with red, showing that's in our x. Same with force of friction, looks like it's completely in our x-axis. And the normal force is completely in our y, so I'm going to overlay that with purple to kind of show that. But we have a little problem with force of gravity since that's not completely on our x or y coordinate plane. So we need to break that down into components. So if I look at Fg, I notice there's a y component of Fg, so I'm going to go all the way down until I can go across according to our modified x coordinate system. So I'm going to say Fgy, which means the y portion of gravity. And I'm going to do the same thing for the x component. So I'm going to go straight across here, Fgx. Now notice the angle that I made is a right angle here because I used the y and I used the horizontal component that is parallel to our x-axis. So we essentially have another x and y force that we want to take care of. Okay, now we want to go to our force equations. So seeing if we can kind of quantify those. So let's start with our y's. That might be easier. So over here, I'm going to put my y forces, and I'm going to say the sum of all the forces in the y direction equal, and I need to figure out what those are. So we have normal force is going up in the y direction, which we denoted as positive. So I'm going to keep that positive in my equation here. And we have FGY going down according to our coordinate system. So I'm going to say minus FGY. But we have a little bit of a problem there because FGY is not actually a force. It's a way for us to show our gravitational force in an x and a y plane. So we don't want that in our final equation. So that means we're going to have to use some trig there. So if we kind of think about our angle being right here, this FGY right here, it looks like that's kind of my adjacent side. And so I'm going to be using cosine to show that. So we have, changing this into FG times cosine theta. And I can kind of fill in the rest of that equation. Fn equals, so now I've got my final equation for the y forces. Let's do the same thing for the x forces. I'm going to grab my other pen here, and we've got x forces. I'm going to create my basic equation again. So I'm going to say F sub x is equal to, and it looks like we have applied force in the positive direction. So I'm going to write FA there. We've got friction in the negative direction. So I'm going to subtract that. And we also have FGX pulling back to the left. So I'm going to write that as negative. So as I look at my equation here, FA and FF are definitely real forces that we've had, but FGX is another force component. So what we're going to have to do is break that down in terms of trig. So if I want it in terms of my hypotenuse, which is h, I have my angle, and I want opposite, that means I want to use sine. So I'm going to put FG sine of theta. And I'm going to fill in the rest of my equation there. And since we know that our object is speeding up the incline, we know these forces overall are not going to be balanced. So I want to leave my x forces just like that because this is a non-zero value because it's unbalanced. But on the y forces, our object is not speeding up or slowing down in our y direction. Otherwise, we'd have some pretty significant problems. So I could say that the sum of my forces is 0 because they're nice and balanced. So then my equation becomes this. And if I wanted to simplify that further, kind of based on my force diagram, I could also say that the normal force going up has to be equal to the y component of gravity going down. And if I want to go back and make sure that my free body diagram is correct, I can also put some congruency lines to show that those two have to be equal.